And here we go, we're in section 9.4, scientific notation. Today I want to look at, and hopefully this is a review for you as far as what scientific notation is, but I want to look at why we use scientific notation in the real world. So we're going to go ahead and play a game here. I want to save money to buy a special birthday present for Brittany, and my plan is to start saving on February 1st and buy the gift at the end of March, which gives me a full 2 months before, and her birthday's mid-April, so I'm gonna be working a little bit in advance here. But here's how I'm gonna save. So first of all, let's look at how many days we have. So there's 29 in that month, 31 in that month, and that gives me 60 days. All right. Now my plan is to put 1 penny in the jar on the first day, 2 pennies in the jar on the second day, and every day I'm going to double it. Okay? So that means if we're looking at days, I'm going to build a little table here. So we're going to have days, and we're going to have number of pennies. Okay? I want you to make this as well. So we have day 1, day 2, day 3, day 4, and so on. Okay, and you can fill those in as you go. But on day 1, I have 1 penny. On day 2, I have 2 pennies. Day 3, I have 4 pennies, and day 4, I have 8 pennies, and I can keep going. I want you to go and pause the video and try to answer this question: how many pennies will I put in the jar on March 31st, or in other words, when this thing gets to day 60? Okay, go ahead and pause the video and try that. Okay, welcome back. Hopefully you had a chance to take a guess at that, or maybe even work it out is what I really want you to do. But let's go ahead and look at this in a different way. All right, what am I really doing here? Well, I'm doubling every single day. Okay, and what that means, the double, or the way to double in math, is raise 2 to a power. Okay, so I'm going to be raising 2 to some n power. All right, now to get 1 when you raise 2 to a power, well, that would be 2 to the 0 power. Okay, 2 is the answer of 2 to the first power. 4 is the answer of 2 to the second, and 8 is the answer of 2 to the third. Okay, and really what we're looking for, and I'm just going to say that there's some stuff that happens in here. I don't want to go over all of those. Maybe you did, but we have a quicker way to do this, and it ends up being 2 to the 59th power, because the 0 power was day 1. Okay, notice that the day and the power, they're off by 1. And so that's pretty important. But 2 to the 59th power, wow, that's going to be a big number. In fact, it's 576 quadrillion, 460 trillion, 752 billion, 303 million, 423,488 pennies. Okay, that's a bunch of pennies. A quadrillion, I've never seen anything in that amount before. Okay, in fact, I can't even say that I've seen, a billion pennies, let alone a quadrillion pennies. So what we're going to do is I'm going to look at this on a calculator. And let me try to get this a little darker. It might be done. That's too dark. Now you can't see it. All right, let's go with that right there. So what I do is I go to mode, and some calculators have this, some don't. Okay, this is a pretty fancy calculator. It's a TI-83. Okay, the most common ones that we have are these TI-30s. And you can do the same thing. Okay. In fact, I don't even need to be in mode. The normal setting that we use in this one is called normal, and in this one here it's called not degrees, but that is normal. It's called flow for float, and it's just floating the decimal. Okay. But what I want to do is I want to go ahead and type in 2 to the 59th power and see what that gives us. All right, well, it says 5.76 and a bunch of numbers, but that's definitely a decimal there. Then it has this little E here. Well, that doesn't mean error, okay? Obviously not, because this is my real answer, and I can see that there are numbers that match up here. This is just scientific notation. It's the scientific notation way to write this same problem. If I looked here and I wanted to move the decimal, I would move it 17 times to put that decimal in between the 5 and the 7 there. Okay, we can even look at that here. So I'm going to take the quick way. The decimal's here. I move it 3, 6, 9, 12, 15 times to get there. 16, 17. So that's 17 moves of the decimal. Okay, and the way we write that is 5.76 times 10 to the 17th. That's what that E means right there, is times 10 to that power. Okay, that's the way a lot of calculators put it. If you're using the TI 30s, and I went 2 to the 59th, I use the same buttons, but it actually shows you a very small times 10 to the 17th power over there. So that's kind of cool that these ones show you that that's what that E means, but we're going to be using this one today. So there are a couple ways to do this. Write each number in standard notation. I want to look at why this works. Okay, if I'm going to write this number, this is in actually scientific notation. If I want to write it in standard notation, really all this is 4.54. Yeah, it's a negative. And then it's multiplying by 10 to the third, which is times 10 times 10 times 10. So 3 tens there. Well, if I figure out what 10 times 10 times 10 is, it's like saying 4.54 times 1,000. Okay? Now, if I multiply that by 1,000, that's the same thing as moving the decimal 3 times. Okay? So we're going to be moving that decimal 3 times. 4.54, moved it 3 times. We have to add a 0 in there. I'm going to use a different color so you can actually see it. But we have to add a 0 in there and put the decimal right there. And we kind of forget about that 1,000. You know, that is what multiplying by a multiple of 10 does, is just move the decimal. So we have negative 4.54, or sorry, scratch that. Negative 454 with a 0 on the end. That's the standard notation. That's what we would rather see. But in science, you deal with such big and small numbers. And I don't mean big negative numbers, but very small as in really close to 0 type of numbers, that they like to use scientific notation so that you don't have to write out all those 17 numbers there. Okay? So let's look at the next one here. In fact, why don't you... or I'm not going to have you pause it yet. We'll do some of that practice later. So when I'm looking at a problem like this, here I was multiplying by a big number. Okay, 10 to the third is a big number. 10 to the negative sixth, that's the same thing as 1 over 10 to the sixth, or 1 with 6 zeros, which would be a million. Okay, that's 1 over a million. So really you're going 3.6 times 1 millionth. Okay, an easier way to do that is, say you have 3.6 and I want to move the decimal backwards 6 times. 1, 2, 3, 4, 5, 6. So the decimal's now there. I always put a 0 in front so I don't miss that decimal. And we have 5 zeros in there. I fill in every one of those bumps there with zeros. So my answer, 0.1234536. Okay. To write in standard notation, we're just going to go the opposite direction. We won't be doing a whole lot of this today, as we are just working with scientific notation. but it's a good thing to know the opposite direction. Okay, here I'm going to be moving the decimal. I need to move it, sorry, I don't know why that says standard. That should say scientific. Okay, and I do take that back. We won't be doing a lot of writing in standard notation. We'll be writing in scientific a lot. So I want to move the decimal 1, 2, 3, 4 times. Okay, and since this is a very small number, as in very close to 0, I know that my decimal, or that my exponent, is going to be a negative. So we get 3.45 times 10 to the negative 4th power, because we're moving it 4 times. This one, it's a really big number, so I need to multiply it by a really big multiple of 10. Okay, so I'm moving it 1, 2, 3, 4, 5, 6, 7 times. Okay, sometimes I'll even say that that's a 7. And we get 9.45 times 10 to the 7th power. Now I'm going to show you a quick way to do each one of these problems. All right, and they're always, there's always a good way, and calculators do really make our lives easier. If you go to mode and you change it to scientific, and I'm just going to quit that. And on these ones, it's the same thing. I want that, see where it says SCI in yellow. I'm going to hit second, that degree button, and I want to move it to scientific. Okay, if I move it to scientific, now if I even write those numbers, just type in those numbers. Let's try this one over here. So it's 0.000345. And if I hit enter on that, it rewrites it as 3.45 times 10 to the negative 4. I'm going to be using a calculator today to make my life pretty easy. But I will show you why it works as well. Let's try it on this one using this second problem. So I have 945, and then it looks like 5 zeros. 1, 2, 3, 4, 5 zeros. Now if I hit enter, I get 9.45 e to the second. That e means times 10. Never write it as 9.45 e to the e7. Okay, that will be incorrect. You have to have the times 10 to the 7 for that to be right. Okay. For these problems, and these are a little bit tricky, but all I really want to do is, they're not quite in scientific notation, but I can type what I have into the calculator and it will give me the same answer. Okay, I'm using these, or this calculator, because it does say the E, and I want to show you, because some of the calculators that we have in the classroom do this as well, and I'll bet your phone does too. Okay, some of them have a little EE button, and I think this one does as well. If I go into math, I don't know, it's not there, it's not there, I don't know, I don't think this has it, but some calculators have a little EE button, and that means, right, oh yeah, this one does, it's the little yellow one right there. It's pretty tough to see. But what I'm going to do is I'm going to type this in and see what it gives me in scientific notation. So 0.7, I'm going to actually put it in parentheses, 0.78 and 758 times 10 up to the negative 5th. Okay, put that in parentheses, and if I hit enter, it'll tell me exactly what I should write. Okay, 7.58 e to the negative 6, and we know that we just write that 7.58 times 10 to the negative 6. So see, it changed my exponent is all it did, and that's all that we're doing here. Another way that you could do these problems would be to simplify this out, write it in standard notation, and then go back to scientific if you wanted to. That's the way that you can do it to never be wrong, as long as you do the process correctly. But go ahead and pause the video, try this problem. Either do it on a calculator or by hand. All right, welcome back. Hopefully you had a chance to get that done. I'm going to practice writing it in standard notation and then back to scientific just to show you that it works. So we get 48.37, and I want to move the decimal 6 times, and it's a big number. So 1, 2, 3, 4, 5, 6. So we get 1, 2, 3, 4 zeros there. Now what I'm going to do is I'm going to go backwards and move it back into scientific. So I want to move the decimal 1, 2, 3, 4, 5, 6, 7 times. And I should get 4.837 times 10 to the 7th power. Let's rewrite this in here and make sure it works. Remember, use parentheses because it just makes life easier whenever you do. So I have 48.37 times, oh, that was a negative, not a decimal, times 10 to the 6th power. And if I just hit enter, excuse me, I get 4.837 e to the 7th. Let's go ahead and turn the page and get the next couple problems done. Now this is where we really get into the work that we're doing, as far as we're working with operations in scientific notation. That's the main part of today. Okay, now the reason it took us so long to get to where we are, all I'm going to be doing is typing these into the calculator just how they show it, and life becomes really easy. But the other way to do it is multiply numbers by numbers and work with my properties of exponents on the times 10 to the certain power. Okay, so negative 4.9 times 10 to the negative 3. And I'm going to be multiplying that by 2.8 times 10 to the 2nd power. And once it's all said and done, it tells me 1.372 e to the 0. Okay, e to the 0. Yep, and that would be times 10 to the 0. Now we can rewrite that because anything to the 0 power is just 1. So I can rewrite that as just the 1.372. Okay, and that would be like multiplying it by 1, but we don't have to do that. Okay, what I'm going to be doing is I'm going to do all the ones on the left-hand side, and I'm going to let you do all the ones on the right-hand side, because that seems pretty fair. Okay, so here we go. I'm just going to be typing this in, 3.5 times 10 to the 5th, 7.29 times 10 to the 3rd. So, again, that's wrong. So, knowing that I have a 10 to the 5th and 10 to the 3rd, my exponent should be at least the 8th. All right, and it actually becomes to the 9th power because 3 times 7 gives me a 2-digit number. But I get 2.55. And I'm going to go ahead and round that to the nearest hundredth. So 2.55 times 10 to the 9th. Okay. Let's look at the next one. 3.7 times, oh, I need parentheses, sorry. 3.7 times 10 to the negative 6th. And then I want to raise that to the 2nd power. You can either use the caret 2, or most calculators also have a squared button. That would work as well. And I get 1.369. And again, I'm going to round that. 1.37. And instead of the e, I want to write times 10, negative 11. All right. That's a very small number, very close to 0. But this shows us a way to write it without having so many digits. Do the next one. It's raising it to the 3rd power. So negative 5.28 to 8 times 10 to the 4th. Raise it to the 3rd. So the 4 and the 3, remember we're multiplying those exponents. So we should have at least the 12th power. And probably a little bit more because we also have to raise that 5 to the 3rd power too. So I'm going to say it's probably the 14th power. And it is. Round it to the nearest hundredth. So 1.47. And that's a negative. Times 10 to the 14th power. Okay. And now let's look at these next couple. Okay, here we're using division. Now you could just look at this and say, wow, 12 divided by 4, that's 3. And 10 to the third divided by 10 to the fifth. So remember that's 10 to the 3 minus 5. That should be 10 to the negative 2. That problem is probably easier to do without using a calculator, but let's just make sure it works. Okay, I'm just setting up my problem. Hit enter. 3e to the negative 2. And so it worked. Let's look at this last one. Okay, we have decimals involved, so I'm just going to go ahead and type it in. 7.25 times 10 to the 8th divided by 3.4 times, oh, I have too many multiplies there, times 10 to the 5th. And so I'm saying, okay, it's probably going to be to the third power, maybe a little bit different. Nope, it is 10 to the third power, or E3. But we have 2.13 is what we're going to have. So we have 2.13 times 10 to the third power. Okay. Again, the easiest way to do these problems is using a calculator. But what I want you to do right now, go ahead and pause the video and try the problems on the right. You've got a lot to do, so take your time and get the problems done, get them done right. Okay, welcome back. Hopefully you had a chance to get those done. And for me, I would just use a calculator. Again, as long as you type it in correctly, you're going to get the right answer. So 3.76 times 10, I'm just going to use the squared button. And 8 times 10 squared. Put in my parentheses. I get 3.008E5. So that's the same thing as 3.008 times 10 to the 5th. All right. Let's go ahead and look at the next one. I'm going to switch this over here so we can kind of see everything. And let's look. We have negative 4.53 times 10 to the negative 2. And then we have 7.28, not 72.8, 7.28 times 10 to the 7th. Okay, with a power of negative 2 and positive 7, we should get something that's close to 5, and we do. We get 6th power. And so that's going to be a negative 3.29. Actually, that 7 is going to make us round up. So that's going to be 30. So negative 3.30 times 10 to the 6th. Okay, make sure we're rounding correctly. All right, next one. That glare from that light is just terrible. What if I turn it off? And then we can't see the screen. Okay, we'll keep it on. Turn on. All right, so here we have 7.8 times 10 to the 5th raised to the 3rd power. And so we get 4. That would be 7.4. But we're going to round that up to 7.5. So 4.75 times 10 to the 17th power. And here we have 4.5 times 10 up to the negative 8th. And we're going to raise that to the 4th. And we get 4.00. Or sorry, 4.100, so let's just say 4.1 times 10 to the negative 30th. So you can see how this makes life quite a bit easier, just knowing how to make the calculator work for you. Let's go ahead and move this down. Last two problems. Okay, we're working with division now. So we have negative 2.25 times 10 up to the second power divided by 2 times 10 to the negative 6th power. Okay. And we're left with negative 1.125, and that's times 10 to the 8th. I'm going to round that again to negative 1.13 times 10 to the 8th. So remember, rounding does nothing to our exponents. Okay, we're just taking away some numbers there, make it a little bit easier to handle. And last one, negative 3.1 times 10 to the 5th divided by 2.1 times 10 to the 8th. It takes a little work to be good at using the calculator, but once you get the hang of it, and most people do, thanks to the great world of text messaging, okay, you can make the calculator work for you, and it definitely helps in cutting down your workload, because these do involve quite a bit of work when you do them by hand, even though they can be done. Okay, we don't want to waste a bunch of time with that. So good luck on the mastery challenge, and make sure you get that practice and the application problems done. Make sure you check all of that. And if you need help working the calculator, making it help you, go ahead and ask me. And with using your phone, it doesn't work as well, but it can be done. So talk to me on how to do that. You really need a calculator that will input more than one thing. So that means either a nice TI-83 or 84 or a TI-30. Okay, multifunction calculators work a lot better than just the basic scientific calculators. All right. So good luck. We'll talk to you guys later. So rounding out our talk of rules of the gym, we had number 4, be careful of box jumps. Number 3, keep your balance. Number 2, control your excitement. And finally, drum roll please, number 1, don't trust treadmills. Enjoy.
What? Alrighty. Jump.
You better not do it slow.